Hi, this is Siddhanth Jain and Yogesh is Naik presenting the project document of microwave oven simulation given by Emertxe in Embedded System Internship. Internship overview. The Embedded System Internship kicked off with the week 1 consisting of C programming, week 2 consisting of project requirements and design of an embedded system and programming, Week 3 consisting of building units and peripherals programming, Week 4 consisting of project integration and testing, Week 5 of Disha workshop. What is a microwave oven? So, we all know what is a microwave oven. A microwave oven is nothing but a device which converts the cold or frozen food into the steaming and hot meals. Why is a microwave oven in our internship program? As we all know, it is a very good, interesting embedded system. We can build projects on using the basic level of understanding using this embedded system. So, coming to the abstract, microwave oven simulation is a project in which implementation of a PIC controller. It has different modes of cooking such as micro grill conversion, and start modes as per the user's requirement. Some of the key features of our project are like four different cooking modes like micron, grill, conversion, and start. Countdown timer for each mode. Temperature can be set manually, generic codes, easy to implement, and real-time status display. Contents. Project development phase, embedded system, components of embedded system, microwave oven components, code overview, simulation overview, challenges faced, acknowledgement. Embedded system. Embedded system is a combination of hardware and software which intended to do specific tasks can be called as an embedded system. For example, microwave oven, traffic lights, TV, camera, refrigeration, etc. Categories of embedded system: standalone, real-time, networked, mobile. Requirements of embedded system: reliability, cost effectiveness, low power consumption, efficient usage of power. Challenges: embedding an OS, code optimization, testing and debugging. Components of embedded system. So this is the overview chart of components of embedded system, which consists of CPU, software, memory. FPGA and ASIC is nothing but the hardware components. Analog to digital converters, sensors, humans, human input-output inference, uh, the diagnostic post actuators, auxiliary system. What should you know about microcontroller? In our project, we have used PIC16F877A controller is used based on some important terms that can be given as host system, a system which is used to develop the target, here our desktop. A target is being developed for a specific application. Here, in our case, it is microwave oven. Cross compiler, an application used to generate a code for another architecture being in this another architecture. Here our usage is MP labs. So this is the architecture of MP labs, sorry, PIC controller, microcontroller, where we can see there are GPIOs, general purpose input output, I2C communication protocol, then temperature sensor, analog to digital converters, buzzers, LEDs, RS-232, a digital keypad, matrix keypad, and CLCDs. Components of microwave oven. The essential hardware components required for the project of the microwave oven simulation are as follows: CLCD and obviously a microcontroller, buzzer, matrix keypad. Software used is like MP Labs for building the code and PixSim Lab for simulation.
Okay, so coming to the block diagram of a microwave oven, as you can see over here, there is a stirrer, a waveguide, magnetron. Magnetron is basically the one which produces microwaves. The waveguide guides the microwave in particular direction, and stirrer cools it in order to not overheat. And cooking cavity is where the food is cooked, and turntable is in order to make the food evenly cooked or distribute the heat all over the food. That is the thing. Door and choke is basically to close the microwave and power supply. So from the diagram, you can see the magnetron is controlled by the processor. There is also thermal protector, which is basically thermistor. Whenever the power is uh, greater than the required, the resistance decreases, and there will not be power supply. So relay is for the delay, and the transformer, bleeder, and filament of magnetron. All the waveguide is to just guide the microwave produced by the magnetron. And as you can see, we have used PIC 16F877A microcontroller, which comes with a lot of specification. It has a frequency of 20 megahertz, which is a variable, and power can be reset. Flash memory, data memory, EEPROM data memory, 15, hardware and software. Okay, so timers three, two are 8-bit and one is 16-bit timers, and all the PWM modules, pulse width modules, USART, PSP, all these parallel communication is possible from PIC. That is the reason why it is used in a majority of our appliances, homemade and others also. Okay, so CLCD is basically to display the whatever what is it? Yeah, if you want to display any ASCII characters or the display module is the CLCD, and matrix keypad is the input of from us. So we give any values, and the microcontroller takes that value. And here the switch on and off is linked with the characters. So one is basically SW5. Whenever the switch closes, one is the character gone. And MPLab is the software which we use, and I will be demonstrating the uh, project now through MPLab and PIC simulator. So this is our main project. We have all the files, main.h, timers, matrix, and CLCDs for the display, and all the other things. So main is we have just uh, assigned, I mean, we have declared the variables, and here we have like defined it completely. So I'll be building the thing in order to create a hexa file and hex file, and to transport or load the hex file in the PIC simulator. So build project. Yeah, so the build is successful. So the hex file is created. So I'll be going into PIC sim lab, where I choose the board. Yeah, this is our PIC 16 F877A microcontroller. It's already been loaded, but still I'll load the X file. So this is the X file generated. I'll be loading it. Okay, uh, yeah, it's already loaded now. So there are four operations: micro, grill, convection, and start. Going with the first one, micro. If I press this one, yeah, it says the power is 900 watts, and it also tells us to set the time. And I'll set the time to 10 seconds for now. And ash is for the enter, so enter. Okay, so the timer is basically on now, and